to do some examples of converting equations between cylindrical and rectangular or Cartesian representations. So if we want to find an equivalent equation in rectangular coordinates, what that means is that when we finish, these should be functions of x, y, and z. There should be no r's and no thetas. Well, the first one, we're actually done. This one is an equivalent representation in both systems because both systems have z. So since there's no r or theta, we're already finished. However, let's go to this second way. If r equals 1/2 z. Well, we know that r squared equals x squared plus y squared. So we can fudge it a little bit, and we can say, all right, if I know r equals 1/2 z, we determined that was already like a circular cone. So what if I multiply both sides by r? Or sorry, what if I squared both sides? If I squared both sides, I get r squared equals 1/4 z squared. And then I know that I have this representation. So I have x squared plus y squared equals 1/4 z squared. And so you need to ask yourself, did I add any additional information? Every time you multiply an extra piece in there, you have to say, did I mess this up some way? And in this particular case, you didn't, because in r equals 1/2 z, you end up going all the way up and all the way down. So you have both the positive and negative situations. So in this particular case, these are just circles. X squared plus y squared equals some function of z. So whatever z is ends up being the radius of that circle. So if z is positive, it's a radius of the circle. Z negative, it's a radius of the circle. And so we have, this is an okay representation. So just something to be aware of. Now in this case, we have z equals r squared cosine squared theta. Well, we know that x equals r cosine theta. So what if I instead wrote this as r cosine theta squared? Well, then I can say z equals x squared. So this is kind of a really good example too. Z equals x squared is a pretty easy to understand function, right? It's a parabola. It's a parabolic cylinder, right? Because z equals x squared forms the parabola, and then it keeps being parallel to that y-axis because y can vary not being there. That's pretty easy to understand. But if I were to look at this, that might be more difficult to figure out. Z is a function of r squared cosine squared theta. You have to think about what r and theta is. It would be it's a lot easier, more straightforward to represent it in this representation. And finally, we have r equals 2 cosine theta. And that one's a fairly easy to figure out situation. That, if you recall from previous studies in calculus or trigonometry, that's just going to be a circle, right? As theta varies, theta goes around the circle, r is gonna sketch that circle. Then if we represent that, we say, okay, r equals 2 cosine theta. Well, what if I multiply both sides by r? Well, then that's x squared plus y squared equals 2x. So that tells me, and so that one may be a little more difficult to figure out, but if you think about it a little bit, that's x minus 1 squared plus y squared equals 1. Now I'll kind of leave you to do the algebra there, but notice that that's just a shifted circle of radius 1. All right. So now if we want to find an equivalent representation in cylindrical coordinates, I have x equals 9. Well, again, remember, that's a fairly straightforward rectangular representation. X is a fixed value, and then it's just a shifted YZ plane. So how are we going to get there knowing what we know. So if x is equal to 9, and we know that x is r cosine theta, r cosine theta equals 9. You could say that, or you could say r equals 9 secant theta. And so that tells you a little bit, but again, this would be a lot more difficult to decipher than just representing that as x equals 9. So some things make more sense in one coordinate, not the other. So z equals x squared plus y squared minus 11. So this looks like a series of circles based on the z value. But I know that this is equal to that, so I can say z equals r squared minus 11. So that's a fairly straightforward one as well. And then finally, we have x squared plus y squared equals 8x. Okay, all right. Well, I could say that's r squared, and that's 8r cosine theta. And then I could probably divide by r without too big of an issue. R equals 8 cosine theta. Or we could look all the way over here and say, well, when I had this equation 2 times x, it turned into that equation. 8 times x turned into that equation. So use the fact of going back and forth to help you understand a little bit about how to traverse between these types.